This is 2012 FRQ number 4 in the non-calculator function. The function f is defined by f of x equals square root of 25 minus x squared for negative 5 to 5. Find f prime of x. Okay, so this one's very straightforward, just looking for the derivative. So f prime of x equals, this is the whole thing, root, that means it's 1/2. Bring down the 1/2, 25 minus x squared now to negative 1/2. Don't forget chain rule, inside you have negative 2x. Clean this up, that 1/2 and the 2 reduces out. You have negative x all over root 25 minus x squared. That is your first derivative, okay? Part B, write the equation for the line tangent to the graph at x equals -3. So tangent means, again, you want the derivative, which we already have. You have the x value, now you need the y value, all right? So you gotta plug the x in 2 times. Plug it into the original function to get the y, plug it into the derivative to get your slope. Okay, so f of -3 is root 25 minus 9, which is root 16, which gives me 4. Okay, f prime of -3, negative of -3 all over 25 minus 9, which makes it 3 over 4. That's my slope. So my tangent line is equal to y minus 4 equals 3/4. X plus 3, because x minus -3 is x plus 3. So this is my tangent line. Okay. Part C. Let g be the function defined by g of x equals f of x between -5 to -3, and then x plus 7 from -3 to -5. Is g continuous at x equals -3? Use the definition of continuity to explain your answer. So we did one of these continuity problems, right? So in order for this to be continuous, the limits and the values have to match. So limit as x approaches -3 from the left side. Well, if it comes from the left side, it's going to come from the f of x side, right? Because this is from the left side, is of g of x equals f of -3. All right, so what was f of -3? F of -3 was 4. Limit as x approaches -3 from the positive side of g of x. That's going to be the second function here, because that's from the positive side coming from this way. So if I plug -3 in there, I get -3 plus 7 equals 4. So great, my limits do match up. All right, so that means limit as x approaches -3 from both sides of g of x equals 4. Now, what is g of -3? Well, according to this, g of -3 is only defined at f of x, so that is going to be 4. So when a limit and the value are equal, that means this is continuous. Okay, so limit and the value have to be the same. All right, last but not least, find the value of the integral between 0 to 5, x root 25 minus x squared dx. So x root 25 minus x squared dx. Okay, this one you will need to use u substitution because you have 2 x's. You have an x on the outside, x on the inside. So let u equals 25 minus x squared. That's your inside expression. du is -2 x dx. Move your coefficient. -1/2 du equals x dx. I would go as far as to plug in the values as well so I can change my entire integral. So u of 5 is 25 minus 5 squared. That gives me 0. U of 0 equals 25 minus 0, which is 25. Okay, so now my new integral is going to be from 25 to 0. X dx now becomes -1/2 du, and then u to the 1/2 power for the square root. All right, so -1/2. U antiderivative is +1, so 1/2 plus 1 is 3 over 2 times the reciprocal, 2/3. Evaluate 25 to 0. Clean this up, so -1/3. You do 3/2, 0 to 25, 25 to 0. So that would give me -1/3, plug in the 0, 0 to 3/2 minus 5 squared to the 3/2, just a little bit easier to work with. So this is 0. I get -1/3 times -5 to the 3rd, so -125. My final answer is 125 over 3, and that's my integral. Okay.